Hello, my dear students. Welcome back to the lecture. So in this lecture, we are going to see the complete IS 456 2000 codebook, and we'll try to understand that, right? So most of the things, whatever I've explained you in my course, everything is taken from the IS codebook. Now, once you open this book, IS 456, there's a new revision which has come, but this is the old one what I have, and we'll try to understand from here. Okay. Yeah. So I think we'll start from the beginning point. So this is IS 456 2000. It stands for Plain and Reinforced Concrete Code of Practice, and this is the fourth version, right? So the new one has come. Yeah. So we'll start with this now. So all these are the contents what you have, right? So directly we'll start with the first part. So if you're not aware about what are the general short forms and symbols, you can always come here, right? And you can try to understand, like, what is A stand for area, B is the breadth of the beam, what is BF is the effective width of the flange, right? So in this way, DF is the depth of the flange. So whatever you're not able to understand, V stand for shear force, T is for torsional moment, T is for wall thickness. So in this way, all the things they have given it here. And then it will start with section number 2, that is materials, workmanship, inspection and testing. Like, what are the materials you're supposed to use, how should be the workmanship, what are the tests you're supposed to conduct, and how the inspection has to be done. So coming to the cement, so we have 33, 43 and 53, right? So anyway 33 is not available in the market. Whatever we have is 43 and 53, and most of the construction what we use is a 53 grade ordinary Portland cement. Now if you want to know more about this 33, 43 and 53, then copy this IS 12269, put it in the Google, download this, and again more thing about its fineness, specific gravity, all those things. If you want to understand in a more detailed way, you can read it from IS 12269. Try to note down this, just in case in future, if you become a quality control engineer and all. So in that case, all these things are useful to you, right? Then again, we have Portland slag cement. Then you have to refer IS 455, Portland pozzolana cement, which is a fly ash base, which refers to IS 1489 part 1. So then we have low heat Portland cement. So in this way, all the things are given here, right? And then other than that, we'll try to, I'll read it out. Yeah. So other than that, this is all okay, right? Yeah. Next, we have understood about the chemical admixtures and mineral admixtures, right? So what are your chemical admixtures? Like plasticizers, super plasticizers, air entering admixtures. Then we had accelerators, we had retarders. All this comes under the chemical admixtures. When it comes under the mineral admixtures, they're also called as pozzolanas. Like we have fly ash, then we have silica fume, then we have rice husk ash, then we have GGBS and so on. So again, it is mentioned here, pozzolana materials conforming to relevant Indian standard may be used in permission of the engineer in charge, provided uniform blending with the cement is ensured. Then about the fly ash, if you want to know more, you can go to grade 1 of IS 3812, and you can understand about fly ash. We have class C fly ash, we have class F fly ash, then what is the specific gravity, all those things you get from here, right? Then again silica fume, then dry husk ash, it is mentioned here. Then of course we have metakaolin also. Again metakaolin and all, we usually when we do our academic project work and all, in that case we try to play with this and try to do lot of blending of a cement, like 50% of cement with this, and then you replace that with the fly ash. And also these are the test what we do in normal construction practice. Usually we make use of fly ash and silica, fly ash and the GGBS. Okay. Yeah. And other than that, coming to the aggregates now, how your aggregate should be, how you have to clean that aggregates, again all those things it will be written here, right? It's written here, aggregates shall comply with the requirements of IS 383. Now if you go to IS 383, okay, there you're going to get complete details about aggregates, what should be the size of aggregate, how you have to use it, and all those things you are going to get in a more detailed way, right? Now other type of aggregates such as slag, crushed overburnt brick or tile may be found suitable with regard to the strength, durability of concrete and freedom from harmful effects may be used for the plain concrete member, but such aggregates should not contain more than 0.5% of sulfates, and should not absorb water more than 10% of their own mass of it. So this can be a good question. What should be the maximum water that is absorbed in the aggregate? So it should not be 10% of the own mass of the water. And other than that, coming to the size of aggregate, again, it is written here. The nominal maximum size of coarse aggregate should be as large as possible within the limit specified, but in no case greater than 1/4 of the minimum thickness of the member. So what is this 1/4 of the minimum thickness of the member? That means if I have a slab thickness of 150 mm, what is 1/4 of that? It comes out to be, let me do that. How much it comes out to be? 150 divided by 4 comes out to be around 33, I guess. Let me do it. 33, yeah, almost 37, almost 37, I think. Let me check it out. 150 divided by 4. Yeah, 37.5. So this is a maximum size of aggregate what you can use in a slab thickness of 150 mm. So again, these are the important points that you're supposed to understand. So it's written here. If somebody asks you what is the maximum size of aggregate you can use, then always remember the nominal maximum size of coarse aggregate should be as large as possible within the limit specified, but in no case it should be greater than 1/4 of the minimum thickness of the member. If it is a beam, then beam depth will be usually 300, 350. In that case, do that, right? Yeah. Provided that the concrete can be placed without difficulty so as to surround all the reinforcement thoroughly. But most work, 20 mm aggregate is suitable. I told you that in most of the RCC work, 20 mm aggregate is what we usually use. So it's written here. For most work, 20 mm aggregate is suitable. When there is no restriction to the flow of concrete into the sections, 40 mm or larger size may be permitted. In case of PCC, so in PCC, you don't put any reinforcement. So you just have to place the concrete. In that case, what we do, we use a 40 mm aggregate. So wherever there is no reinforcement and all, and there is no congestion in placing, in that case, you can make use of 40 mm aggregate. Otherwise, most of the construction, what we do is a 20 mm aggregate, right? Yeah. Now coming to the water. So again, water used for mixing and curing shall be clean and free from injurious amount of oil, acid and all. Of course, we know that. Then other than that, you do the testing on the water and all. That usually we do in the environmental lab also. And other than that, yeah. Again, how do you, like I already explained this test, how can you do the testing of the water on the site? Then again, it is mentioned here. See, average 28 days compressive strength of at least 3 150 mm concrete cube prepared with water proposed to be used shall not be less than 90% of the average strength of the 3 similar concrete cubes prepared with the distilled water. Now let us say on the site you have brought the water, but you don't know the quality of that. In that case, what you can do, you make 3 samples of that water of for a 150 by 150 by 150, and then for the same aggregate, for the same mixed design, for the same ratio, instead of water, make use of distilled water. Now once you do that, the whatever answer you're going to get from this normal water, no, it should be at least 90% of the strength what you got with the help of distilled water. So read this point again. Average 28 days compressive strength of at least 3 150 mm concrete cubes prepared with water proposed to be used shall not be less than 90% of the average strength of the 3 similar concrete cubes prepared with distilled water. The cube shall be prepared, cured, and tested in accordance with the requirement of IS 516. Again, IS 516, if you go, it will tell you how the testing and all those things are to be done. So this is already covered in my course. I mean, I already explained you how we can do the water testing on the site. But again, all these things are given in the code book. If you understand it from here, then you can show it to anyone and you can have a better technical knowledge. Yeah. Again, we can see it here. The initial setting time of a text block made with the appropriate cement and water proposed to be used shall not be less than 30 minutes and shall not differ by plus or 30 minutes for the initial setting time of the test block. This we already say how the test block has to be done. Then pH value of water shall not be less than 6. Always remember this. The pH of a water should not be less than 6 because what will happen? It becomes acidic in nature. So as far as possible, we keep it neutral. The water which we use for drinking, the same water we can use it for the construction work, right? Yeah. So again, these are the permissible limits of the solids, which is already covered. I've explained you all these things. So you don't have to remember all these things. So if they ask you how you do the testing for the water, you can tell about it should be neutral. It should not be less than 6. Then you can tell this is a test what we can do on the side. And then this is, if you can remember, like organic, inorganic, sulfates, chlorides, we try to keep it within the permissible limit. Well and good, enough. Yeah. Now coming to the admixtures. Again, admixtures we know whenever we want to improve the whenever we want to modify the properties of a concrete, we try to make use of the admixtures. So this is about the reinforcement, how the reinforcement should be there. It should be free from all the rust, scales, loose rust, and coats of paint and all. Okay. And then now coming to the storage of materials. For storage of materials, already I've shown you for the cement how the stacking has to be done. It's like first in, first out, right? And after that, I told you how the stacking will be done. If it is a cement bag, then we are going to keep it one above the other. If it is an aggregate, we are going to make a heap out of it. If it is a bricks, we are going to keep it one above the other. So all those things is written in the code book. I've already explained you from there. Yeah. So these are the grades of concrete, and these are the specified characteristic compressive strength of 150 mm at 28 days. If I want to prepare a M25 grade of concrete, the minimum compressive strength or the characteristic strength, what I'm supposed to get after the end of 28 days, it should be minimum 25. So all those things it is written here. And then other than that, yeah. So this is a tensile strength of a concrete. So they may ask you, what can you tell me the tensile strength of a concrete? So the tensile strength of the concrete is 0.7 square root of FCK. Tensile strength is also called as flexural strength. You can see it here, the flexural and the split tensile strength. Okay. So this is a formula where FCK is the characteristic compressive strength. So it means at what is the first point, at what load the first crack is going to come in a concrete. So that is a flexural strength. Okay. For example, if I tell you I'm giving you M30 grade of concrete, tell me the flexural strength of this. So what you're supposed to do, 0.7 into square root of, yeah, square root of, I'll make it easy. Instead of 30, I'll go with 25. It's easy for me to. Okay, I'll write square root of 25. So square root of 25 is 5 and 0.7 into 5 is 3.5. So at 3.5 Newton per mm square, the first crack is going to come in this particular concrete, right? So that is the meaning of the flexural strength. And always my flexural strength is, or my tensile strength is 10% of my compressive strength. Whatever is a compressive strength, because concrete is strong in compression and it is weak in tension. That doesn't mean that it will not take tension, it will take tension, but how much? Only 10% is going to take the tension, right? So that is the meaning of that. Other than that, this is a modulus of elasticity, what we call EC is equal to 5000 square root of FCK. Again, it will be used in the designs and all. Okay, but again, yeah. Then coming to the shrinkage, we don't have. Creep is not required. So creep is it's a long term what you call deformation. What will happen? Right? I already explained this in my concrete technology course in a more detailed way. Uh, so if you put a load on anything and if you keep it there for a very long period of time, then what will happen? A certain settlement is going to happen. It's going to get compressed. So that is called as a creep, right? So again, other than that, next thermal expansion, we know about the steel and the concrete. And this is already we have seen what is workability. I'll explain it in a more better way. Then you don't have to remember all these things, but it's mentioned here. But usually if you're doing a pumping concrete and all, 120 mm is a minimum slump that you're supposed to keep. Otherwise the concrete will not flow through that pipe. Okay. So other than that, they have mentioned all these things based on the requirement, based on the mixed design, we try to do that. Yeah. So again, this already I've explained you how about the environmental exposure condition. What is mild, moderate, severe, very severe, and extreme conditions. Then come to the concrete cover. Yeah. Yeah. So from here, whenever we do the mixed design and all, from here we'll get to know. Suppose if I want to do for a moderate exposure, and in that case, if I'm doing for RCC, then what will happen if I'm doing for a moderate exposure, and if I'm doing it for the RCC, okay, this is my reinforced concrete. Then what will happen? I need to take M25. M25 is my minimum grade what I'm supposed to take, and maximum water cement ratio what I can take is 0.5, and minimum cement I'm supposed to take it as 300, right? So from here we try to do the mixed designs and all. So I can try. You don't have to remember the chart, but just understand with the help of this exposure condition, we are going to decide what should be my maximum water cement ratio and what should be my minimum cement content in that. Again, they may ask you what is the minimum grade of concrete used in RCC. So it is minimum is M20. Okay. if you're doing a concreting in a seawater in the coastal region, then you're supposed to use M30 then. Okay. Yeah. So again, what you're supposed to understand from here is that, see, minimum for RCC construction, we have to use M20. This is a minimum requirement. If you're doing it in the near the coastal region or near the seawater, for PCC, you're supposed to use minimum M20, and for RCC, you're supposed to use M30. This is what is written here. So you can read it out. See it here. Concrete in seawater or exposed directly along the sea coast shall be at least M20 grade in case of PCC, that is plain concrete, and M30 in case of reinforced concrete. Got it? So it's the same thing. I've written it here. I can remember that. But in normal and all, usually we go with a PCC of M7.5, M10. That is what you're supposed to do it. See, these things are not required. If you're interested, you can go through this. This is in more detailed way, where that explanation or that level of knowledge is not required at this level. Okay. Next, I told you about the quality assurance, that a quality control and a quality assurance and all. So again, it is a quality assurance what we do. Yeah. One more thing, see, whenever we do mixing, when we do the mixing of cement and all, we have two options, right? Either you can make use of a batching plant, either you can make use of a batching plant, where all the raw materials will come on its own. Second is that we make use of a hand mixer. So whenever you do make use of hand mixer, you have to add 10% more cement content. You have to add 10% more cement content, because since it's a hand mixing, what will happen many times whenever you put the cement into that, let us say by mixed design or with the help of mixed design, you got that you're supposed to use, you have to add 50, you have to add 50 kg of cement. Okay. Or let us say I'll add 100 kg. Now when you do hand mixing, exactly 100 kg will not come, because when you pour the concrete, when you pour the cement into that mixer, there's every chance your cement may, half of the cement may fall there, right? Since we all are humans, we are supposed to make those mistakes. So the code says that you have to take 10% more of that, and then you do that. So what will happen, it will compensate all those things which you already done. Like if there is a wastage and all, it will compensate that. That's the first thing. Second is that they may ask you one more question, that when you do the mixing, okay, when you do the concrete mixing, how long you're supposed to do. So the best answer is that you have to do it for 2 to 3 minutes. Like, you first, what you're going to put, always remember, first we are going to put coarse aggregate. After coarse aggregate, we are going to put sand, and then we'll try to mix it. Okay, we'll rotate that. Once it is properly mixed, then we are going to put the cement. Why is that so? Because if you put cement first and if you put sand later, then what will happen, there won't be proper mixing of that. And since cement is very finer, what will happen, a lot of particles will go in air, right? So that is why first we'll put coarse aggregate. Once you put the coarse aggregate, what is going to happen, since coarse aggregate, I mean, they are coarser in size, like this is how the coarse aggregate will be once you put them, right? Then what will happen, when you put the sand into that, whatever holes are there in between this, whatever holes are there, whatever voids are there, that will be filled by the sand, because sand particles are finer, right? And then when you put the cement, now when cement is finer than sand, whatever gap is there in between this sand particles, that will be filled by the cement. So in this way, what will happen, you will have a proper mixing. Once you do that proper mixing, you'll add water, and then you make an entire concrete. Now, how long you have to do that revolution, how long you need to do the mixing? So the best answer or the best time is 2 to 3 minutes is the best thing. 2 to 3 minutes. Now, next question will come. So what will happen if I do it beyond that? If you do beyond that, we have many problems. I'll write it here. We have to do it only for 2 to 3 minutes. That's the best option. If you do beyond that, what will happen? Since you're doing it for the more number of times, maybe you're doing it for 5 minutes, what will happen? You have a coarse aggregate, you have sand and all. Now, coarse aggregate, what will happen? There's a term called as attrition and abrasion. What is attrition? If two materials of same nature, if they collide, we call it as attrition. Abrasion is like if two different materials collide, we call it as abrasion, right? Now, since we have coarse aggregate, what will happen if coarse attrition? All right, attrition is going to happen. What is attrition? There are many coarse aggregate. So coarse aggregate and coarse aggregate, if they try to come in contact with each other, every time they rub, what will happen? The dust is going to come out. So what will happen? The dust will come, right? Very simple. You take two coarse aggregate, try to rub against each other. That is called as attrition. What will happen? The dust is going to come. So what is dust? They are finer in nature. Finer in nature. So if they are finer in nature, what will happen? We are already adding a water. Since you have mixed it for more number of times, more dust has come. If more dust has come, already the water you have added, considering the water cement ratio, the water which is there from workability point of view, that water will be taken by the finer, right? Since they are finer in nature, what will happen? Your surface area has increased there, right? So water will come in contact with that. So whatever water we have added from workability point of view, all that water will be taken by the finer. So in this way, what will happen? Your workability will decrease. So that is why what we do, we never do the mixing of a concrete for more than 2 to 3 minutes. If you do that, what will happen? Due to the attrition of the coarse aggregate particles, powders are going to form. That is, fine particles are going to get generated. And since that finer in nature and we are adding water, so more amount of water will be utilized by them. So that means the durability, that means the workability is going to come down. So that is why we don't do that. Okay. So yeah, it's written here. See, you can see it here. Yeah, what is written here? For guidance, the mixing time shall be at least 2 minutes. I told 2 to 3 minutes. So 2 to 3 minutes is the best time for mixing. For other types of more efficient mixer, manufacturer recommendation shall be followed. For hydrophobic cement, it may be decided by the engineer in charge. Why he has written for hydrophobic cement? Now understand what is hydrophobic cement. In hydrophobic cement, we try to add a layer to that. It is a layer of which one? That is acid, right? So what will happen? Until you break that, your cement is not going to react with the water. So if I want to break that, I've told you in hydrophobic cement, we do rapid mixing. So when you do rapid mixing, that means you have to mix it for a long number of time. And yeah, that is why in hydrophobic cement, as told, the engineer is going to decide. Okay, again, maybe the company which is manufacturing hydrophobic cement, they'll inform you like you have to mix it for so and so number of times. So they are going to do, but understand the logic behind that, why it has to be done. So that is important. This anyone can show you from the code book. Yeah. Then other than that, see, this will take time for you to understand, but if you understand all these things, it's always good. Yeah. Again, coming to the mixer, it's written here. Concrete shall be mixed in the mechanical mixer. Okay. And the mixer should comply with IS 1791 and IS 12119. The mixer shall be fitted with water measuring metering. Why it is telling in this way? Because what will happen usually? People take a bucket and add water every time. If they are supposed to add 1.5 liter of 1.5 bucket of water, sometimes he may add 1.5, sometimes he may add more. But if you are fitting that with the water measuring, if I want to add only 10 liters of water, only 10 liters of water will come. In that way, what will happen? The quality of your concrete that you're manufacturing will become good. Okay. The mixing shall be continued until there is a uniform distribution of materials and the mass uniform is color and consistency. If there is segregation after unloading from the mixer, the concrete should be remixed. And for guidance, the mixing time shall be at least 2 minutes. At least 2 to 3 minutes is what you can do. Okay. But don't go beyond that. But you should know what will happen if you go beyond that. That is very important. Where many of us don't know, but we tell that we have to mix it for 3 minutes. Yeah. Again, when it comes to the dosages of the plasticizer, the super plasticizer, I told you that we add it in terms of percentage, like 0.5, 1%, 2% and all. Okay, by the weight of the cementitious material. What do you mean by that? Let us say I'm adding 100 kg of cement. So how much percentage of admixtures I can add? So it depends. They'll write all these things in the mixed design chart. So let us say 0.5% of this, or let us say 1%. What is 1% of this? 100. So 10, it comes out to be 1 kg. So we'll add 1 kg. For 100 kg of cementitious material, you have to add 1 kg. Now understand one more point. This guy here, it has written, they have written it here. What they have written? Dosage of retarder, plasticizers and super plasticizers shall be restricted to 0.5, 1 and 2% respectively by weight of cementitious material. He has not mentioned cement. Why is that? It is cementitious material, because when you go for PPC cement and all, right, what will happen? You just don't add cement. Agree with me? You add cement, you add, let us say, GGBS, okay, and let us say you are adding fly ash. You are adding fly ash. Now, all these three, they are cementitious material. We call them cementitious material. Now, let us say cement, you are adding 80 kg, okay. I'm taking some random values. Now, GGBS, you are, yeah, okay. GGBS, you are adding, let us say, 25 kg, okay. And then fly ash, you are adding, let us say, 15 kg. Now, when I say I want to add 0.5% of plasticizer to this, 0.5% of not the cement, it's a cementitious material. So what you're supposed to do, 0.5 into, add all these things, 80 plus 25 plus 15 comes out to be how much? So this comes out to be 25 plus 15 is 40, 120. So 0.5 into 120, 0.5 into 120 comes out to be 60, half of that, right? So 60 kg, right? Yeah, I'll check it. 80 plus 25 plus 15, 120 and 0.5 of that, 60 kg. So 60 kg, you're supposed to add all these plasticizers. Got it? So in this way, you're supposed to do that. And yeah, so this is 0.5, not, I did one mistake. Okay. See, that is why I was thinking it's not, because 60 kg is, it's on a higher side. It's practically not possible. What I'm supposed to do is, see, it is written 0.5%. So what I've done is 0.5 or multiplied. Okay. It's 0.5 divided by 100. And then you multiply this by 120. Then you're going to get the answer. Because when I did for 80 kg, I got only 100 kg, I got only 1 kg, right? So this is practically not possible. So 0.5 divided by 100. Yeah. And then I'll multiply this by 120. It comes out to be 0.6 kg. So 0.6 kg of a plasticizer you're supposed to add it. Very simple. Yeah. So this is percentage here, percent. Okay. Yeah. Now this is for the formwork and all. Like when you do the formwork, when you do the shuttering, sometimes what will happen, there is small deviation, right? You cannot, sometimes what happens is small deviation. Now how much deviation is allowed, it's written here. The formwork shall be designed and constructed so as to remain sufficiently rigid during placing and compaction of the concrete, and shall be such as to prevent loss of slurry from the concrete. For further details regarding the design, detailing, etc., reference may be made to IS 14687. Now if there is any complex shuttering to be designed and all, we refer to IS 14687, and all the things, like at what distance you're supposed to keep the props, or what is the thickness you're supposed to use for the batten and all, everything is mentioned there. Okay. Now it's written here. If it is for a column and a beam, okay, you can go with plus 12 minus 6 mm. That is a deviation what you have. Deviation from dimensions of the footing, dimension the plan, eccentricity, this is for the how much offset you're going to give, and then the thickness. If in thickness, if it is for the slab and all, so plus or minus 0.05 times the specified thickness, right? So this is how it is. So in this way you're supposed to do, but usually most of the time we try to check with the plumb and all. But again, if you want to understand this in a more better way, this is what you're supposed to do, the deviations and all. Okay. Yeah. Yeah. Now this we already understood, I guess. Like when you're supposed to remove the formwork and all, if you're putting it for the footing, soon after 24 hours you can take it out. For the column also you can take after 24 hours, because they are vertical element. So it's written here, vertical formwork to the column, walls and beam, you can take it after 24 hours. Even the beam outside shuttering, what you do, that also you can take out after 24 days. Now if you're putting it for the beam bottom, okay, that is beam soffit, then the code says all these things. After 7 days you have to remove the props, take out the beam bottom and refix the prop. Practically we don't do that. We wait for at least 15 days if it is a small beam or a small slab. If it is a large span beam and if it is a large slab and we have enough time cycle, we take it out, everything, the props and the beam bottom and the slab centering, after 21 days. Okay. So they have written it here, like soffit's formwork to the slab. For the slab, what you're supposed to do, after 3 days you can remove the centering, then again you have to refix it. Those things practically not possible. So all those things it is mentioned here, but whatever I told, you can go with that. Okay, yeah. But again, it depends. Here they have written one thing: while the above criteria of strength shall be a guiding factor for removal of the formwork, in normal circumstances, when the ambient temperature does not fall below 15 degrees Celsius, that means if you're doing the concreting work in a cold climate and all, where the temperature is mostly around 9, 10, 11 degrees Celsius and all, especially at the time of winter season and all, okay, and where ordinary Portland cement is used, adequate curing is done. Following striking period may deem to satisfy the guideline given in 11.3, right? So it's telling that if your temperature is less than that, in that case you have to personally go to the site, check it whether the concrete has gained the strength or not, and then you can do the de-shuttering, right? So that is mentioned here. Yeah. So again, it's written here: the number of props left under their sizes and deposition shall be such as to able to safely carry the full dead load of the slab, beam or arch, as case may be, together with any live load likely to occur during the curing or further construction. That means whatever props and all you have kept, sometimes what we do, we take out the props, everything, then we keep one or two props. So make sure when you're keeping the props that it is able to take the self weight of the beam, and if you're adding additional load in the floor, then it should be sufficient to take care of that. So that is what is meant here. But usually we go with after 15 and 21 days, and we'll try to keep certain props there so that the load doesn't come directly on the beam. Okay. Again, this is for the concrete. Unless specified otherwise, the actual concrete cover shall not deviate from the required. Whatever cover we have, no, it should not deviate from 10 mm. Okay. And chairs, spacers, chairs, and other supports detailed on drawing is not required. Welded joints. Yeah. This is about the transportation and all, how you're going to do the placing. Like I told you about the free fall of a concrete, right? Whenever we pour the concrete, we should not make the concrete fall from the height above 1.5 meters. So it's written here. So as a general guidance, maximum permissible free fall of a concrete may be taken as 1.5 meter. So if you make it fall above 1.5 meter, then the segregation is going to happen. And if segregation happens in the column and all, then honeycombing will happen. So that is why we usually avoid that. Okay. And about this is about the compaction. Concrete shall be compacted using mechanical vibrators. Comply again. I told you those are called as poker needles, or you call it as a needle vibrators. 20 diameter, 40 diameter, 60 diameters available. Now again, if you refer IS 2505, IS 2506, IS 2514, so everything is mentioned here. What should be the diameter of that? What is the specification of your vibrator and all? Everything is written here. Okay. Over vibration and under vibration of concrete are harmful and should be avoided, and vibration of very wet mixes should be avoided. So whenever you should not do over vibration, because if you do too much vibration, the formwork and all may get displaced, and there's a chances of your cement slurry and all coming out from that. And under vibration is also should not be done, because if you do under vibration, there's every chances it may result in what you call honeycombing. There's every chances your coarse aggregate may remain in the bottom, the cement slurry may come to the top, right? So proper vibration has to be done, especially in the zones wherever there is a column beam junction, where there is more reinforcement and a lot of congestion. So you cannot do under what you call that, under vibration there. Got it? Yeah. Yeah. Now about the curing. So curing, it is written here how many days you're supposed to do the curing and all. So what I can tell you is, come here, for at least 10 days where mineral admixtures or blendeds are used, the period of curing shall not be less than 10 days for concrete exposed to dry and hot weather condition. In case of concrete where mineral admixtures or blended cements are used, it is recommended that the above minimum period may be extended to 14 days. It means that you do any structural element, be it your column, slab you forget, slab anyhow we are going to do it curing, footing, column and all, minimum 10 days curing you have to do. Okay, if you're using an ordinary Portland cement. And if you're using a PPC cement, okay, it's written here blended cements, like if you're making use of fly ash, GGBS and all, in that case you're supposed to do the curing up to 14 days. So that is why I told you, when we when we use a PPC cement, what will happen? The strength gain will not happen quickly. Why is that? The fly ash and GGBS, they don't give you a rapid gain of strength. The 7 days strength what you get in OPC, the same strength you're going to get in pozzolana cements at the end of 10 days. So that is why when the strength gain itself is slow, then obviously you have to do a lot of curing. So that what will happen? I mean, you have to do a lot of curing. So that is why it is written, it is recommended that above minimum period may be extended up to 14 days. So that is why you usually don't go with PPC cement, because if you spend 14 days in doing curing and all, your construction process will come down. So that is why we try to avoid it. Okay. Yeah. Membrane curing, we have seen how the membrane curing will be done. Yeah. Then again, if you're working in a cold weather conditions and all, then again they have given IS code book here. Refer here. Through that we can do it. But again, initial level it's not required. Whenever you go to the higher level and all, then of course you can always come check out the code book what is written and all. Okay. Yeah. So this is about your grouting and all, how the grouting has to be done and all. It's not required. Yeah. Okay, this is for the sampling and all. This usually we use when we are preparing the concrete, when we are doing a mixed design and all. Okay, how many samples you are supposed to take and all. The minimum frequency of sampling of concrete of each grade shall be in accordance with the following. Let us say if you are manufacturing or if you are preparing 20 cubic meter of a concrete, then how many samples of cube you are supposed to take. So if it is a 20, it falls under this condition, 6 to 15. In that case, number of samples you can take 2. Suppose if you are doing 40 m cube, so it fall under this condition, 31 to 50. In that case, you're supposed to take 4 samples. Anything above 51, you have to take plus 1 additional sample for each additional 50 m cube or part thereof, right? So in this way, all the samples will be given. I mean, it is given here frequencies, number of samples you're supposed to take, but most of the time you go with the 3 samples only. Okay. Additional sample may be required for various purposes, such as to determine the strength of concrete at 7 days, time of striking the formwork. Additional samples may also be required for testing the samples cured by accelerated methods and all. Yeah. And also, how do we do the test on the cube? We cast 3 samples and we check the average of that 3. Okay. And whatever average we are getting, that should not deviate by plus or minus 15% of the each individual. That is what is written here. See what is written. The test result of the sample shall be the average of strength of 3 specimen. The individual variation shall not be more than plus or minus 15% of the average. If more, the test results of the sample are invalid. Yeah, what it means, for example, let us say I've done 3 cube testing. Okay, first I got 25 strength, I'm telling. Second I got 27. Third I got 28. Now let us say I did an average of this. So quickly I'll do the average of this. 25 plus 27 plus 28. 80 divided by 3. 26.67. So 26.67. So this is my average. Now it says that whatever average I have got, no, this answer should not deviate by plus or minus 15% of your individual answers of your individual. That means now you do this. What is 15? Okay, I'll do it for you. Do 15% of this into 0.15. Okay, right? Wait, 26.67 into 0.15. So it is coming 4. Okay, that means 26.67 minus 4. So it should lie in between 22.67. Okay, to 26.67 plus 4, 30.67. Your answer should lie in between 22.67 to 30.67. Now come and check here. Okay. Now come and check here. 25, this is my individual test result. Is it falling in between this? Yes, it is greater than 25, less than 30. Good. This is okay. 27, obviously it is more than 22, less than 30. Okay. This is 28, greater than 22, less than 30. Good. So If more, the test results of the samples are invalid. Just in case if this was like, let us say if instead of 28, if this was like let us say 32 I got, okay, then again average also will change, but no issues, we'll consider for your understanding. Then it is deviating by more. 30.6 is maximum what I can do, but I'm getting 32, then I'll discard this. Again, you have to do the mixed design. Before doing mixed design, try to do again the same sample. Sometime what will happen when you fill the sample and all, proper compaction you are not going to do, in that case such problems will occur. Okay, yeah. Yeah, so done. Okay, up to here we have covered it. So next things we'll try to take in the next lecture, other part and all, so that we get a complete idea how this code book is supposed to be understood. If you understand even little things, it's enough, because it will take long time for you to understand. We'll see you back in the next lecture.